So welcome to today's session. We are doing some computations for the factors of production. And remember last time we were just looking on the theoretical part regarding to the factors of production, which is labor. We did labor entrepreneurship. We have lands, and we have what else? What else do we have? Or we have not been reading?
We have labor.
And capital, right?
Yes.
Now, based on the computation, I just want to be brief for you to understand about these computations. Because when you look on the computations here, let me just share my board. We are doing factors of productions. Factors of production theory. The theory we are doing computations, sorry. So these computations, I just want us to look on two scenarios here for the purpose of understanding. We have to be looking on the functions formulas. And these are the formulas which already we know, basically based on the general knowledge. One of the things here which you're supposed to be knowing, number one, we have to be discussing about how do we normally get our revenue function? How do we normally get our revenue function? That is our R here. So it means to get our R, we normally take P times Q, where our P is equal to the selling price, right? Then we have our Q, which should be the number of units. The number of units sold. Now, number two, we have to be looking on the total cost function. Which is now, to get my TC here, we normally take F plus VQ, right? Where our F is equal to the total fixed cost, right? VQ here, we talk about the total variable cost, right? Where our V is equals to the variable cost per unit. The variable cost per unit. Then we have our Q. These are the number of units. The number of units we are producing. So the number of units produced. Number three here, we can be able to discuss about profit function. We have different methods for computation of the profit function, which is normally noted by that sign. So, but in statistics, when you just want to calculate the profits, can you be able to take the total revenue minus the total costs? The total revenue minus the total costs. Or sometimes we normally discuss about to get our profits, being able to take the contribution margin X minus fixed costs, where the M is equal to the contribution margin. Contribution margin. And we ask ourselves, how do we normally get this contribution margin? We say, we normally take our selling price minus variable cost. Right? Normally take the selling price minus the variable cost. When we look on this X here, we discuss about the number of units, the number of units sold. Then this F of ours here is the total fixed costs. Just want to break these formulas for you to be able to understand better. Now from there, it is very crucial for us to be able to understand a small concept here, whereby we have to be analyzing something called, normally called marginal analysis. And when you want to look on the marginal analysis, because it touches most about what we're going to be doing. So under the marginal analysis, because I have the function formulas here, the marginal analysis, when you look on the marginal analysis here, it is where we are going to be coming across two scenarios. We shall be able to come up with two scenarios. And I remember last time I said, this is the analysis. It is the analysis of, it is an analysis of revenue function. It is an analysis of revenue function. We also talk about cost function, analysis of revenue function, cost function, and profit function. And profit function in order to determine the optimal quantity, in order to determine the optimal quantity, to produce and sell. So the most important thing that you need to know here, under the marginal analysis concepts, we just need to, because already we know how to compute our total revenue function, the biggest question should be, how do I normally calculate the revenue, average revenue, for example? So we say, if we want to calculate the average revenue, we say, can you be able to take your total revenue, you divide by the quantity? The total revenue you divide by the quantity. That is how you can be able to get the average revenue. You normally take the total quantity, total revenue, you divide by the quantity. And when you look at it, we are going to be making a lot of understanding regarding to the second concept here, where we have to be discussing about the marginal revenue. The marginal revenue stock the marginal costs, right? And in this case, because we just want to introduce ourselves to calculus and so on, it means if, for example, I've been given the total revenue, right? And then my requirement is I need the marginal revenue. It means if you want to come from here to the other side here, we said we have to be doing something called differentiation. We said we do differentiation, but if we want to do the other side here, we said we are going to be doing integration. And these ones normally opens up a gate for the computations of the calculus. But in this case, what we just need to master here, it is the formula for differentiation, right? This formula is going to be as if you understand those notes of yours. So we have n, ax, right? N minus 1. It means if you are computing a differentiation equation, right? You're going just to be taking you're going to be pulling down the power. You pull down the power, and then you are going to be able to reduce the power. But if you want to do your integration, you just need to take the marginal revenue function, or it should be the marginal costs, and you want also to get the total cost here. So what am I supposed to be doing on the other end? It means I'm going to integrate. And integration, it means we are just reversing an equation which has already been differentiated. So in this case, we're going to be having ax, n plus 1, then you divide by the new power, n plus 1. We will be able to check on that as we do a lot of questions. Number 3 here, we need to know if an examiner is asking us to calculate the average costs. It means if I need to get the average costs, basically it is just taking my total cost function, I divide it by quantity. That is a good formula which will be able to assist us to determine whatever nature of questions we want to do. And when you look at it, because we normally say at profit maximization, we say the marginal revenue should be equal to the marginal cost. At the profit maximization, the marginal revenue should be equal to the marginal costs. So that being said and done, is it possible for us to do these illustrations? Let us look, for example, the table which I was able to share earlier on with you. What does it entail? So when you look on this table of ours here, already examiner is doing, or it has already been computed here. Now, if you look on because already you are being given the average fixed costs, average variable costs, you also be given the average costs and the marginal costs. Now, in this case, when you look at it, you'll be able to see an examiner is just providing you with the relationship between these variable costs and what does it entails when represented in a graph. You can see that the marginal and the average revenues are cutting across at certain stages, and then also being affected by the average variable cost and the average fixed cost. That is how the graphical representation of those cost variables normally look like. It is very important for you to be able to master it. Now, when you look on the aspect of illustrations already for one, which we are already be given here, an examiner is asking us, can we be in a position to get the marginal cost function? Because already he has given you the total costs, but he just wants us to calculate the examiner wants us to calculate the marginal cost functions. If that is the case, and already we have an equation, let me just rub here. So if we have that equation now, and we want to get the marginal cost functions, I'm just going to be using my differential functions formula, to be able to determine what the examiner wants. Now, in that case, we will be able to calculate let me just first pick the equation. Our equation is looking like this. These are my equation now. My equation normally is looking like this. The total cost is equals to Q squared plus 3Q plus 2, right? That is your total cost. And when you look on the 2, it does not have any Q, correct? So in this case, when you look at it, the 2 does not have Q, and this is your fixed cost. If the examiner might be asking, what is the fixed cost? I'm supposed to be telling him or her it is 2, the one that does not have any variable. Now, in that case, remember our examiner is asking a requirement number A to get the marginal cost function. The marginal cost function. And we said, if, for example, we are being given the total cost and we want to get the marginal cost function, we can do differentiation. We can differentiate. The question is, what is the formula for this differentiation? What is the formula for differentiation? And we say it very well. To get our formula here, you normally take n, ax, n minus 1. How can I be able to apply that formula in this equation? It means you're going to be pulling down the power and we reduce it. And the areas where we don't have Q, we ignore it. What do I mean? So to get my marginal cost here, we are going to be saying, because I just want to apply this formula, what is my new power? What is my power here? I say, well, the power which I just want to pull down is 2. So it will be 2 times Q. Then we want to reduce this power, 2 minus 1, right? Plus, remember now, this q is raised to power 1. So if we pull down the 1, it will just be 1, right, times 3. So let me just say 3q 1 minus 1, correct? Then this one, it is normally even a throwaway. We cannot be able to analyze it because it does not have q. Now, in that regard, because already we are looking on something which we are able to look here, we are looking at to get the marginal cost. You have just said, let us take the change of the total cost over the change of q, which will be, now, what is the answer for this? It will be 2q, right? 2q plus 3. Why am I putting 3 there? Because our q here is reduced to 0. Our q here is reduced to 0. So to get our marginal cost functions, it will be 2q plus 3. 2q plus 3. 2q plus 3. That is the answer. Now, number 2, an examiner might be asking us to compute the average total cost function. That is our B. Is asking about the average total cost function. So to get the average cost function, we said, can I be able to take the total cost function? We divide by the quantity. And we say yes. What is my total cost here? It will be q squared, right? Plus 3q plus 2 here. Correct. And remember, because we want to take our total cost functions, we divide it by q, right? It's just like dividing all of them by q. So in this case, it means if you take q squared divided by q, we are going to be remaining with 1q here, right? Plus 3 now, because this q and this one, they will cut across. Then plus 2 divided by q. 2 divided by q. 2 divided by q. This is your answer now to get the average total cost function. That is how we normally get it. That is how we normally get our total cost function. Now, number 3, as per the requirement of the examiner, he is asking us to compute the average variable cost function. Very good. See here, he's asking about the average variable cost. The average variable cost function. Now, remember here, we have to be very keen regarding to how do we normally get our total cost. And we normally get our total cost by taking we normally get our average variable cost function by looking on the analysis of the total cost. Remember the total cost, it is when we get our total cost, we normally say, let us take the fixed costs plus the variable components. This is the variable cost. That is your variable cost, right? Then this is your fixed cost. So it is a combination of the two. But we don't want the fixed cost. What do we want? We want the variable cost functions. So when I look on my equation here, it means 2 is the fixed cost, and we don't want it. So the variable component is these 2. So it will be, if you want to get the average, first we have to be analyzing how much is the variable cost from that equation. And we say the variable cost of ours will be q squared plus 3q. Q squared plus 3q. So in this case, it means I need a variable for this. This is the variable which I need at the average variable cost functions. And it is very simple. It means if I want to get the average variable cost, I'm going to be taking the variable costs, we divide it by q. In simple terms, I will just be able to take the q squared plus 3q, we divide here by q. What will be the answer? If you take the q squared divided by q, you remain with q plus 3q divided by q, it will be able to get the 3. That's how you are going to be getting the the average variable cost function. That is how you are going to be getting the average variable cost function. Now, there is another question regarding to the same, where an examiner is asking, at what level of output will the firm minimize its average total costs and its average variable cost in short run? Right? And in this case, it means we are going to be quitting. We are going to be saying, can we be able to take our, at that level, because the examiner is asking, it is just like equating the marginal cost functions, which we have here, with the average total cost functions. Because the examiner is asking us, at what level of output would the firm minimize its average total cost and its average variable cost in the short run? So in this case, in this scenario, what we are supposed to be doing is that requirement D now. I'm just following. Yeah. Okay. Now I have said in a very simple way. If you want to do this question, it is very important for us to be able to say the change, which is our marginal cost, should be equal to the average total cost. The marginal cost will be equal to the average total cost. Try to see, can we be able to minimize the cost in the short run? And in this case, we say, what is the formula for the marginal cost functions? I say I was able to get 2Q plus 3, which should be equal to the average total cost functions, which we have already gotten, Q plus 3 plus 2 over Q. The first thing that we're supposed to be doing is by removing that Q. Right? And we'll be able to remove that Q from that equation. And we say we can. So in this case, it means, can we be able to remove it by multiplying here by Q and also multiplying here by Q? We just want to remove it there and be able to solve our equation. So in this case, we are going to be having 2Q squared plus 3Q, which should be equal to Q plus 3 plus 2. Right? 3Q plus 2. No, this should be, if we multiply here, it should be looking like what? Okay. Yes. So if we multiply here, this equation should be looking like, it will be Q squared plus 3Q plus 2. Right? It's just like doing something called on the average total cost functions. It's just like doing an integration by reversing back the equation the way it was. So it is just like taking our original equation, right? It's just like reversing it to our original equation. So in that regard, it is possible for us to get the like terms together. And we'll be able to get the like terms together here. And we say, you're going to be saying 2Q squared minus Q squared plus 3Q minus 3Q. It should be minus 2, should be equal to 0. We just need to equate the equation. So our equation will be looking like what? It will be Q squared minus 2 should be equal to 0. But you ask yourself, what is the value of the Q? Right? It means our Q squared will be equal to 2. But we need to get the Q. At what level of output? How many numbers of, what is the value of the Q in simple terms? So the value of the Q will be, and it's going to be determined by rooting now, to remove this power here. And then we root our 2. So it means, to get my Q, I should be taking the root of 2. We should be equal to what? The root of 2 is how much? How much is the root of 2? And in this case, we say the number of units which can be able to maximize all that should be equal to 1.41. 1.41. right? 1.41, 1.41. Okay. So 1.41. Yes, that is the answer for the Q. Now from there, when you look on the, any questions so far? Any question? Any question? Now let us look on the second illustration for the purpose of understanding. Let's look on our second illustration. Our second illustration discusses about, it is here. Let me share with you. Okay. There is someone who is calling herself Zoom user. We don't know who is Zoom user. Now, exercise 2, we are being told here, suppose the total cost functions of a firm operating in a short run is given by, we have been given the total cost function there, which is equal to the Q squared plus 5Q plus 6. We have been required to find the average total cost function, the marginal cost functions, the average variable cost function. But down there, we are being told, calculate the average fixed cost where Q is 3, and we'll be able to look at it. Then the other one, we're being told, what will be the value of the following at the output of 100 units? A, we have the average variable cost. B, the average fixed cost. C, we have the marginals. Then we have number 4, where we are being told, at what level of output will the firm minimize its average total cost by average variable cost? We shall be able to look on that. Now, in this case, let us start our questions here by copying our equation. So how will our equation look like? How is our equation looking like? How is our equation looking like here? So our equation will be able to look like, examiner has given us the total costs. So we say, to get my total cost function here, the total cost functions which have been given, it will be Q squared plus 5Q plus 6, right? Then, examiner is asking us, number 1, the average total cost function. We say, to get the average total cost functions, is it possible for us or to allow us to take the total cost to divide by our Q? So how much is our total cost functions? We say, it is our Q squared plus 5Q plus 6, and then you divide all of this by Q. So Q squared divided by Q, it will be Q plus, right, 5 now, plus 6 divided by Q. That is how you get the average total cost function. Secondly, examiner is asking us to compute the marginal cost function. Number 2, the marginal cost function. And I have said, when we have the total cost function, then you need to get the marginal cost function. What are we supposed to be doing? We said we normally differentiate. So what is the formula for differentiation? N, AX, N minus 1. So in this case, it means we need to pull down the powers, all areas where we can be able to find the Qs. If you find an area without the Q, you ignore it. So in this case, our equation here will be change in the total cost over change in Q should be equal to what, right? We say it should be, if I pull down the power, it will be 2Q, 2 minus 1, plus now 5Q, 1 minus 1. Here you ignore it. We don't have Q. So the marginal cost function will be looking like what? Our marginal functions will be 2Q plus 5. This is how the marginal cost function look like. Now, number 3, I can see the examiner is asking us to compute the average variable cost function. Number 3, the average variable cost function. The average variable cost function. And when they're asking about the average variable cost functions and they give you the value of Q, that is just confusing you, right? What would be the value here? Because we are going to be using that later, that is somewhere else. In this case, it means I have to be identifying my variable cost here. And this is my variable cost. So I'm supposed to be taking the Q squares plus 5Q, saying this is my variable cost. That is my variable cost. So how am I going to be getting the average variable cost? Is by taking the variable cost, we divide it by Q. Just give me 1 minute, please. We were doing the average variable cost functions, and I have said to get that variable cost functions, we just need to take the variable costs, divide by the Q, and in this case, it will be Q squared plus 5Q, we divide by Q, getting Q plus 5. Getting Q plus 5. Q plus 5. Now, when I look on a requirement here, which is requirement number 4, what will be the value of the following, right? What will be the value of the following at an output of 100? Okay, let me see here. So calculate the average fixed cost where, what is our average fixed cost? So in this case, because we are being told to calculate the average, to calculate our average fixed costs, if Q is equals to 3. Very simple. You remember very well, because we want to calculate the average fixed cost, we have to be taking the fixed cost divided by Q. Then from this equation, you ask yourself, what is our fixed cost? We say our fixed cost is equal to 6. So 6 divided by Q. But knowing very well, our Q is equals to 3. So what will be the average fixed cost? It is 6 divided by 3. We are getting 2. We are getting 2. Now, what will be the value of the following outputs of 100 units, right? So number 4A, they are asking us about the average variable cost. The average variable cost. And to be able to get our average variable cost, we know very well we have to be taking our variable costs. And I remember that one we have already done here. But we have been given the value here. The output level of ours should be 100. So how can I be able to determine this? We say, to get the average variable costs, we said we have to be taking our variable costs, we divide it by Q. The average variable cost, we have to be taking the variable cost, we divide by Q. So in this case, it means that the output level of ours, we know it, right? What is our output level? The output level provided we are being given here, it should be around, we are being given the output level and the output level of 100. So in this case, it means if I can be able to pick my variable cost here, the variable cost, our Q now is equals to 100. We say, let me take 100 squared, right? Plus 5 times 100. We divide both by 100 because our Q is 100. Correct. Our Q is 100. So in this case, it means, what will be our answer here? How much would be our answer there? How much is our answer? So our answer is very simple, because this one is coming to 10,000 divided by 100, right? Plus 500 divided by 100, right? So how much is your answer? How much is our answer here? Our answer should be equal to 100 plus how much? Plus 5, which would be equal to 105. 100 plus 5, which should be equal to 105. It will be equal to 105. Now, the next one we are being asked about number B. What is our B here? Examiner is asking very well. What is the average fixed cost? And you remember we have said, to get the average fixed cost, we take the fixed cost to divide by Q. So in our case here, we have 6. Divided by, our Q is 100. We are getting 0.06. 0.06. It is very simple as that. Then the other one, we have been told about, examiner is discussing about the marginal cost, that is part C. And we say to get our marginal cost, right, we need to integrate. So we take the change in the total cost over Q, change in Q, right? And in this case, we can be able to see, in this case, you can be able to see that if we want to integrate this equation, the marginal cost, okay, we differentiate, sorry. So if we want to differentiate this, we said we normally take n ax n minus 1, n ax n minus 1. And in this case, because already we have differentiated somewhere, we have q somewhere to build 2q plus 5. So to be able to get the marginal cost of our,
Just brush, but you didn't brush your tongue, so you're gonna skip.
huyu ako na sisi kweli. Na yuko na sisi. Now, to be able to look on the total cost, the marginal costs, we just need to equate our Q to 100, and it will be 2 times 100 plus 5, which will be equal to 205. Which would be equal to 205. 205. Now, what else now? The last requirement we were being asked, which is our, at what level of output will the firm minimize the average total cost by average variable cost? I remember I said we just need to equate the marginal cost with the total cost functions, right? So in this case, we just come here, you say, that is the last one. We say the marginal cost is equal to the total cost, right? So the marginal cost of ours is how much? We say the marginal cost is equal to 2q plus 5, which will be equal to q squared plus 5q, right, plus 6. And I said last time, can we be able to put the like terms together? Is it possible for us to put the like terms together? And we say yes, we can be able to do so. So it will be equal to what? It will be equal to q squared. Can you be able to take, you can take these ones on the other side. So it will be q squared, we don't have q squared here. Then plus 5q minus 2q, right? Plus 6 minus 5. 6 minus 5, we should be equal to 0. You equate to 0 now. So our equation will be looking like what? q squared plus 3q, right? Minus 1 should be equal to 0. Should be equal to 0. Are we together to that point? Are we together to that point? There is a mistake somewhere. For better understanding, let me do it like this. Let us say the marginal cost should be equal to the average total cost. So the marginal cost of ours should be equal to how much? What was the marginal cost? Okay. It was 2q plus 5, which was supposed to be equal to, what was the average variable cost? The average variable cost was how much? We had the average variable cost. It was q. Was it q plus 5 plus 6 over q? And then we say, just multiply both sides with q. And there we are going to be having 2q squared plus 5q. We should be equal to the q squared plus 5q plus 6. Correct, yes. It should be looking like that now. Now, in this case, we say, let us put the last term together. It will be 2q squared minus q squared plus 5q minus 5q. We should be equal to 6. So in this case, it means that it should be q squared is equal to 6. The root of this, to remove that power. Our q should be equal to how much? What is the root of 6? What is the root of 6? So to get the root of 6, should be equal to 2.45. The root of 6 is 2.45. Something that we cannot be able to do that now. So the value of q, which will be able to minimize the cost in a short run, should be 2.45. Any question at that point? Any question? Any question? Any question? Now we can do the revenue functions. Revenue functions. Under the revenue function, we are saying the revenue is the receipt from the sale of goods or service. So the total revenue, all of these equations I've already introduced to you. So allow me just to do these illustrations. When I look on this exercise 4.4, give a demand function of P is equals to 5 minus a quarter Q. We are being told to calculate the revenue, marginal revenue, the total revenue, marginal revenue, and the average revenue, Now, we are saying that that does not have any problem. We can be able to do it. So, be able to solve that equation. Let us just solve that problem very fast. We say to get our total revenue, we normally take the price multiplied by the quantity. The price is multiplied by the quantity. And because I can see the examiner giving you the price functions here. So what is our price function? I can see here the price function is given by 5 minus a quarter Q. So it means I have to be taking my price function, which is 5 minus a quarter Q, we multiply by Q, so that we can be able to get the total revenue function. So to get the total revenue function, we are going to be saying, and it should be 5Q, right? Minus, can I use point 0.25 Q squared? 0.25 Q squared. That is our total revenue function. Total revenue function. Then I can see also examiner is asking for the marginal revenue. And we say that note number 2, from the total revenue to marginal revenue now, we need to do something called differentiation. We do differentiation there. Now, to do our differentiation, we said we take n, ax, n minus 1. It is the same concepts. So we pull down the power. Remember, this q is raised to power 1. So it will be 5 q 1 minus 1 minus these 2 now. 2 times 0.25 q 2 minus 1. So in this case, it should be the marginal revenue of ours should be equal to what? 5 minus 0.5. It should be 0.5, correct? 0.5 q. 0.5 q. And also I can see they're asking about the average revenue, number 3. The average revenue. And we said, to get our average revenue, we normally take the total revenue. We divide by Q. How much is our total revenue? We say that the total revenue of ours, the total revenue functions, we were able to get 5Q minus 0.25 Q squared. Then you divide it with Q. So in this case, it will be Q divided by 5Q. It will remain with 5 minus 0.25 Q squared divided by Q, getting 0.25 Q. 0.25 Q. 0.25 Q. That is how you normally get it. That's how you get it. Maybe able to do another one? Yes. Let me display it there. So given this equation here, right? I know that this one is very clear, but given this equation here, we are talking about the price function. The price functions provided, the P is equals to, we are being given 3Q. It should be 3 divided by Q plus Q minus 5. But to remind ourselves, to get the total revenue, we need to take the price times quantity. So how much is our price? We say our price is 3Q, 3 divided by Q plus Q minus 5. Then all of these we divide by Q, or we multiply by Q, sorry. So in this case, it will be 3. Because of this Q divided by this, Q cancels. So we are going to be remaining with 3 plus Q squared minus 5Q. Minus 5Q. That is our total revenue function. Now, if we need to get the other one, which they are calling it, the marginal revenue, to get our marginal revenue, we differentiate this equation by saying the change in the total revenue over change in Q should be equal to what? Remember now, when we differentiate, we don't have any Q here. You know that, right? Here we don't have any Q. So in this case, it will be, if you pull this power down here, it will be 2Q, 2 minus 1, minus 5Q, 1 minus 1. So how much it is? This will be 2Q minus 5. That is our marginal revenue. Now, the other thing is, what is the examiner is asking? The examiner is asking about the average total revenue, which I'm supposed to be taking the total revenue. You divide it by Q. And in this case, the total revenue functions of ours will be 3 plus Q squared minus 5Q. You divide it by what? You divide it by our Q. So in this case, we are going to be having 3Q plus Q, right? Minus 5. Minus 5, minus 5. Minus 5, minus 5. Are we together at that point? Are we together to that point?
Kindly explain at the marginal revenue that change of TR over change of Q.
This one?
Yes.
Or this one?
E, the one of change of TR over change of Q, which is equals to Q power 2 minus
This
1.
is just the differentiation. The differentiation we just normally just equate. If we want to differentiate, we normally say the change in total revenue over change in Q should be equal to N, AX, N minus 1. It is just the application of the formula. It is normally, it looks like that, based on the analysis of the differentiation aspect. So, it being here and failing to put it, it does not say that you're not going to be getting your marks. So, this is how we normally get it. And you can just equate. It's just an explanation of the application of our formula, which we have been using there, which you are using. For example, when you look on your computations, they are not prolonged because they don't apply the quadratic formulas. They don't apply the quadratic formulas. So, if they apply the quadratic formulas, I will be able to explain what does this mean. But sometimes if it doesn't make sense to you, you just leave it. It is not of great importance at this level. Now, I just need to stop at that point. In the evening, we shall be looking on the optimum size of the farm as we conclude the factors of production. Is that okay? Are we in agreement up to that point?
Yes.
I expect everyone to be here and read. I normally know when the people are not reading. Just put the videos and so on. So from my hand, I can see we are here to start reading, and I hope we should preparations, early preparations are better. Okay. I wish you a nice Sunday. See you in the evening.
Same to you, Mwalimu.
Okay, bye-bye.
Blessed day.